Hey, so some of you may be wondering why we need to use this mole thing. So we've been looking at this mole idea and molar mass and what's the whole point of it. And so what I'm gonna do, I think what we're gonna try to do to get a feel for what the purpose of this is we're gonna take a look at a lab that you normally would do in the lab. We can't do it because we can't go into the building, but we'll just start looking at some observations. So it involves a couple different things. It involves nails. So if you just have like regular iron nails, and then it involves something called copper chloride. And copper is, if you take copper chloride, it's like a bluish greenish crystal. If you dissolve it in water, it's the copper chloride is in the water. And what I'll make kind of and we looked at some things called ions earlier. If you did the early part of the work, you know that some of the things that we kind of have, like table salt or whatever, they are ionic compounds, and they are things that are charged, that are stuck together. And so we'll look at copper chloride, which is an ionic compound, and we dissolve in water, something happens to it. And then when you put the nail in the copper chloride for, a couple hours, and if you just, even after a few minutes, you start seeing a change. But if you let it sit there for a couple hours or even longer, then you start seeing some significant changes take place. And so I'm going to show you the video of what that is. And as we start looking at what is happening in this reaction, we'll get more into, well, maybe have a better idea of why we need this mole thing that we end up using. Okay, so here we go. This is the lab that we're talking about. If you look at the chemical equation, so the chemical equation, we haven't dealt a whole lot with chemical equations, but we have this substance here, iron, Fe. The S stands for solid, and then we have copper chloride, CuCl2, and that's AQ, that's aqueous. And aqueous just means that it's dissolved in water. So if I have a solid, if I have this substance here, which is copper chloride, the crystal, it is a solid, but if I put it into water, it looks like that, and it's aqueous. And then the arrow tells me I'm forming a couple things, FeCl2 and copper S. So I don't want you to think too much about the equation, but I just want you to start looking at what's going on here. Let me close my picture here. If I have copper chloride, the first thing is what is the charge of the copper and what's the charge of the chlorine, and how do we know that? So we talked about charges of ions earlier. How do we figure those things out? If it's in solid, and if we have in the liquid form. Iron, because it is a solid, it has no charge, so that's why this is showing with no charge here. Okay, so that's the first question. It's like what is the charge of these things? And then when I have a solid, this is because it's a solid, it's actually a crystal, and the CuCl2 tells me that it's in a 1:2 ratio. So it's not just telling me that there's one copper and two chlorines. There's actually millions and billions of atoms stuck together, but it's in a ratio of one copper to every two chlorine. So as we start looking at this here, questions become, what is the iron look like in this nail? So what do you think? Models are really important. So how do you think the iron is packed in this nail? Is it packed tightly, loosely? What's going on? Why? What evidence do we have to tell me that this nail is, the atoms are like this in this nail. If you know a nail, you can just like, the physical properties of a nail. What is the physical property of the nail? Tell us about how the atoms are. Same thing with the copper chloride. In this solution, how do you think the copper and chloride ions are in this solution? Are they going to be stuck together? Are they going to be apart? Are they something else? So kind of talk about what do you think is happening here? And then when I put the nail into, before anything happens, so before any reaction takes place, hypothetically, what do the atoms look like? So where are the atoms in this iron nail and copper solution? And then what we're going to start looking at is what's going on afterwards. So this is the original nail. This is the original copper chloride solution. And you can see here that something is happening. If I let it sit for a couple hours, this is what happens. Okay, so the nail, you can see what's going on. I just want you to write down, like, what is some evidence that you have that something is changing? What do you see in this beaker that tells me that something is actually happening to the atoms here? Okay, so don't look at the chemical equation or anything. Just look at the physical evidence. What do you see? Look at the original substances and look at this and what do you see happening? And then I want you to make a prediction. What do you think is actually happening? What do the atoms look like in this after it is starting to look like this? So you can see this picture here. I just want you to draw, what do you think, or describe where do you think the atoms are and why do you think that? Where do you think the copper atoms are, the chloride, the iron, where do you think is all going? And what's possibly happening here, okay? So that's your first task before we start getting into the mole stuff, and then we're gonna go from there. All right, good luck.